this out in parts A, B, and C to guide your thinking. But of course, test day, you're not going to see parts A, B, and C. What you need to be able to do is read that and decide what you're up against. First hint, in a chemistry problem, if it says specific gravity, whip that immediately into density, okay? Because we as chemists always work density. It's those medical people that work specific gravity. So it says specific gravity is 1.31. Bruce, can you whip that into density for me?
1.31 grams per milliliter.
Perfect. Remember, it's just a comparison of the density of the substance to density of water. Density of water, liquid water. Pedro, what is it? Okay, I caught you off guard. The density of pure liquid water at normal temperatures, what is it? It's an easy one. Tran, say it out loud for us. 1.00. That's why it's the same. Okay? All right, you were thinking about the weekend coming up or something. Okay. So, if you have specific gravity, no units, because if you went from here to here, you'd have 1.31 grams per mil divided by 1.00 grams per mil. Okay, numerical value doesn't change, but units get trashed. So we can go directly from here to here. That was your big clue 1, specific gravity. You know, when you're taking a test, circle those big clues. Specific gravity, think, I remember she said, whip it into density immediately. Okay, then, they're saying this percent is by mass. So when they say we have 100 mils of the solution, now let's look at this 100 mils. I wrote it like this. Up there, it's typed differently. When I write it like this, Kassan, how many 6 when it's like this? 3. And when I have it up there, Andrew, how many? 4. Okay, so I just took the liberty, since that had 3, I'm just going to put that down to 3, although you can keep your 0 if you wish. But if you trash that like 0, be sure to keep your decimal place though. Okay, so I have 100 mils of solution. That if I'm ever going to do that percentage problem, because it's by mass, if I've got the volume of the solution, I can get the grams of the solution. So what's our plan? Emily, what would you do to go from here to here? Okay, so what's the equation you're using, the expression? D is equal to M over V, but we've got the mils and we've got the density. She went ahead and said she'd rearranged it, but let me just put it this. Okay, it's M over V. Okay, now, again, there's a couple of ways to approach this. Do it whichever seems better to you. If you like to take this, and you know you got to solve for M, well, you want M standing alone. You could take it as the symbols, multiply both sides by V, so that M stands alone. Okay, so D times V is going to give you M. And now, another word of caution. M is the unknown. I've got it hanging out on the right-hand side. In math, the unknown is almost always hanging out on the left-hand side. If that's problematic to you, whip the whole thing around. Okay, so if I put it this way, because I just manipulate the numbers instead of the symbols. But we'll end up the same way. We're going to have 1.31 grams per mil. And I'm going to be careful and keep the units. Okay, now look at those units. Alex, what cancels on units here?
Milliliter.
Yeah, mils on the bottom, mils on the top. Be careful how I write, because I got the G slant instead of making it G very specific over mils. And we say, aha, that's the unit we wanted. And so, makes the math pretty easy here. Nicole, how many grams? 131 grams. Now, of what at this point? Is it of water? Is it of the H2SO4? Is it of the solution? Solution. Those densities or specific gravities are always for the whole solution. So we have this many grams of solution. Everybody holding up all right? No one step is very hard. What makes it hard is to put a string of steps together and decide where to start. With specific gravity, get it into density. Once you got density, you think, do I have the units I want? If they give me mils, but I need grams, use the density and change it around. Okay, so let's move over here. I have 131 grams of solution. Okay, but I want grams of the pure H2SO4, the sulfuric acid. Okay, Steve, what do I do next? See, I've got 100 mils, but I already know that's 100 grams of solution. And I can go back here. Out of this is 40% the pure stuff. How do I get 40% of that? Sure. Okay, now, would you let me do that? But 40? What should I do, Steve? You're taking a percent. What do we have to do? Decimal. Where do I stick my decimal, Steve? Yeah. Because it's, remember, parts per 100, 40 over 100. But we're so clever, we whip that decimal over 2 places and not write that whole thing down. And so, percent has no units. Here we are with grams. So when we multiply this out, we're going to get grams. And I'm going to give myself another 0 so we can hang on to 6. Okay, so everybody have their calculators out? If you don't have one, come and grab one of mine. And Alex, what did you get to the correct number of 6?
52.4.
52.4. Okay, 6 okay? Right. And you got 3, had 3, you started with 3. Now, is the number realistic? Yeah, because 40% I think, it's about half. So it's about half of that. Yeah, I'll go for that. It's a little bit less than half. So you can make estimations to see if it's a realistic answer. Are we okay with this 117? Okay, now, your task is later today, as soon as you can, let a couple hours go by, look at that problem again, using your notes and stuff, and wait maybe 48 hours, look at it again. And that's the short-term memory going into long-term memory. Try it that last time with no help at all. If you need help that 3rd time, okay, get the help you need by a friend or your notes. Then do it a 4th time until you get to that point. You can just look at that and say, hey, I know what to do. Okay? All right, let's move on. The next one, we did a heat problem, but this is a harder heat problem. It's also going to be like something we're going to do in the laboratory, not the next lab, but we have a lab doing a specific heat, just like this. Let me get rid of some of this extra stuff.